All right, welcome back. So now what we're going to do is talk about the number of solutions. So if you remember back when we were doing two systems of two equations and two variables, so system of two equations with two unknowns, we were talking about how those are graphically represented by lines, right? So we're talking about lines that either intersect or they don't intersect, right? And we were talking about intersecting lines, right? So if we have two lines that intersect, we have one solution. If we have two parallel lines, then we have no solutions. Or we have two lines that are the same line, they represent the same line, or they're right on top of each other, and we get an infinitely many solutions. Now, when we talk about three equations in three variables, or what I usually say is three equations with three unknowns, now we're talking about planes, right? So an equation with three unknowns represents a plane, right? X, Y, Z plane, okay? So if we have three planes, right? If those three planes intersect, they could intersect where we have the result is a line, a solution that's a line, where it means that there's infinitely many solutions, right? So if we have planes that intersect such that they form a line, the intersection of all three planes creates an intersection line, if you will, then there's going to be infinitely many solutions, and we would say that the equations, right, the equations are what? Just like with two equations and two unknowns, we would say that the equations are dependent. Okay? Now, what if we have planes that are parallel? Or what if we have okay, so here's an example. We could have parallel, all three planes could be parallel to each other, so they never intersect. Or we could have two planes that intersect, but the third plane is parallel to one of the other two planes. So that won't give us a solution, right? Or we could have all three of the planes intersect, but they don't intersect let me explain it this way. So the planes intersect, but let's say one plane intersects the other one, but doesn't intersect the third. And then the other two planes intersect, but doesn't intersect with the other one. So let's say plane A and plane B intersect, but plane C doesn't intersect both of those, right? Or plane C and B intersect, but plane A doesn't intersect C. So they're all intersecting each other, but they don't all three intersect each other at one point or in one location, if that makes any sense. Okay? So there are three options. So in either one of those three cases, we have no solution, right? And then of course, and so that would be the case where the system, right? The system is inconsistent, right? Just like before. And then of course, the planes could intersect where they all intersect at one point, okay? Which is like in the last two examples that we did, we showed that, hey, we only got one order triple. So there could be one unique solution, like in that case. There could be no solution, where in the case that the system is inconsistent, or we could have infinitely many solutions where the equations are dependent. Okay? So now we'll do some examples and move forward.